I'm Don Hoffmann. I'm a professor of cognitive sciences emeritus at the University of California at Irvine, and I'll be talking about conscious realism. When you look at your face in the mirror, you see the color of your eyes, the texture of your hair, the shape of your face. You have a lot of conscious experiences. If you're brushing your teeth, you have the taste of the toothpaste. So we have conscious experiences. We think that most humans share experiences much like ourselves. We think that perhaps cats also have conscious experiences. I can tell if my cat likes the food that I'm giving it, or likes when I'm petting it, or doesn't want to be pet. Probably a mouse has conscious experiences. It probably can smell cheese and taste cheese. It probably likes certain things and doesn't like certain things, at least it feels certain things. When we get down to microbes, we're less certain. We begin to wonder, well, you know, they're alive, but do they have conscious experiences? Do they sense their environment, but do they experience their environment? We begin to wonder. And then when we get down to things like rocks, we're pretty sure that there are no experiences going on here at all. And if we get down to even subatomic particles, you know, like protons and neutrons and quarks and so forth, then we're pretty sure that we're in a realm where there's no conscious experiences. So we have a way of attributing conscious experiences to some of the creatures and objects in our world and not to others. And we have a question when it comes to, for example, artificial intelligence. Could a machine be devised that's complicated enough or complicated in the right ways enough that it might be conscious? And there we have lots of debates. We're not, in many cases, quite sure. And most of our intuitions come from a physicalist framework. And in that framework, space-time and its contents are the fundamental reality. So in this framework, it began 13.8 billion years ago with a Big Bang. Space and time came into existence together with all the energy that eventually transformed into all the particles that we see around us and particles that we don't see, dark matter and dark energy and so forth. And so this is the picture that we have, that it was an impersonal beginning, a pure space-time, no consciousness, no life. After hundreds of millions of years, maybe billions of years, the first life may have arisen in the universe. And then who knows how long after that, consciousness first flickered into existence. And so conscious experiences, if they're real at all, are very much, from this point of view, latecomers in a universe that really fundamentally is unconscious and will eventually extinguish consciousness, you know, as we go to asymptotically to a state where, you know, the universe no longer allows consciousness to exist. So in this view, space-time is fundamental, and what's also fundamental are particles. These are the particles of the standard model of physics, the quarks and gluons and so forth. So this is fundamental reality in their particles. And as we go up from the most elementary particles and so forth, where in some sense we think that we find the deepest laws of nature, we go up to higher levels. We get to things like pyramidal neurons. Those are going to be higher level objects in this physical universe, but they're just physical systems. And then we get to entire brains, and those are also, from this point of view, just physical systems. And so from that point of view, it's very natural to think that when it comes to explaining our conscious experiences, that somehow it's brain activity that's fundamental. The physical system of the brain, the neurons and the particles are fundamental, and that somehow that gives rise to our conscious experiences. That is just a natural conclusion from this whole framework in which the Big Bang and space-time are the fundamental nature of reality. and in which we can, in some sense, in a reductionist fashion, go to smaller and smaller scales in space-time to find deeper and deeper unifying laws. So the reductionist framework has proven very, very powerful for the last several centuries in physics and science more generally. So why not go that way with consciousness and the mind-body problem? How is consciousness, our conscious experiences of colors and headaches and emotions of love and so forth, why shouldn't those also in some sense either be just illusions in a purely physical world, or if they're not illusions, merely products somehow of neural activity, which is more physical and fundamental. So that's the standard view in which this is thought about. And in that framework, it makes sense to say that if we can eventually understand how the brain creates conscious experiences, then we should eventually be able to download your personality, your conscious experiences into a computer and simulate and recreate your conscious experiences, or the illusion of your conscious experiences. So when we have some really intense experience like the splash of color, we know that there are brain areas that are highly active. There's serious correlation between brain activity and conscious experiences. So for example, when you see color, area V4 in both hemispheres of the brain tends to be highly active. And if you have a stroke in the left hemisphere of your brain in area V4, you end up with something called hemiachromatopsia, where everything in the right part of the visual world is in shades of gray, and everything in the left part of the visual world you see in color. So here's a case where there's this very, very tight correlation between brain activity and conscious experiences. And in fact, if I take a magnet, transcranial magnetic stimulation device, and touch it to your left hemisphere, just on the skull, near V4, and inhibit it, then I can temporarily, or people who use TMS units can temporarily give you this experience of loss of color in just half of your visual world. When you take the magnet away, then your color comes back. So it sure looks like we have a nice causal relationship between brain activity and your color experiences. But of course, correlation does not imply causation. That's a truism in the sciences. The rooster crow is correlated with sunrise, and in fact, the rooster crow typically happens before the sunrise, but none of us think that the rooster crows caused the sunrise. And so there is a legitimate question about, even though there are these correlations between brain activity and conscious experiences, that maybe the correlation does not imply causation. So this is the mystery of consciousness, the hard problem of consciousness. How exactly is the brain activity related to the conscious experience? What is that relationship? What we want as scientists is a precise statement of that correspondence between conscious experiences like color and brain activity like area V4 activation, and what is the causal relationship, if any, between those. So that's the hard problem of consciousness. Leibniz understood this problem back in the early 1700s. He understood that it was a very, very hard problem, and so in the 3 centuries since, we've been working on it, and it's still a big open problem. And what's remarkable is that in the last 20, 30 years, there have been a lot of scientific theories about conscious experiences. For example, integrated information theory, global workspace theory, neuronal global workspace theory, and orchestrated collapse of microtubules. What's remarkable is that none of these theories can explain even one specific conscious experience. So in the case of integrated information theory, right, there's supposed to be some kind of integrated causal computational architecture that is identical to or gives rise to each specific conscious experience. And what I've asked Giulio Tononi a couple times, recently, in fact, the last couple of years, so great, so give me one. What is one specific conscious experience and the integrated information causal structure that's identical to it? Can you give me one? And he can't. And same thing with global workspace. There's not a single specific conscious experience that can be explained. And in the case of the orchestrated collapse, I've asked Stuart Hameroff, the very same question in public at a conference. And no, there's not a single specific conscious experience. So that's where we're at. The highline scientific theories can't explain even one specific conscious experience. So that's why we still call it a hard problem. We can't explain the taste of chocolate. We can't explain the smell of a rose. We can't explain the sound of a saxophone. There's not any one specific conscious experience that can be given a precise, mathematically precise physicalist explanation. I'm not saying it can't be done. I'm just saying it has not yet been done. So what's the problem? Why, the physicalist framework has been so successful for so long. Why are we having trouble here? And I want to turn to what our best scientific theories today are telling us. The best scientific theories tell you when they reach their limits. That's the power of a really good scientific theory. It succeeds in certain areas, but then it tells you, at this point, I stop and I can go no further. So in physics, we have the realization in the last 20, 30 years that space-time is doomed. Space-time has been the fundamental nature of objective reality in the physicalist worldview for centuries, at least since Newton, probably before. And physics has been about what happens in space and time. That's what physics has been about. And what physicists are now saying is that the very notion of space-time itself cannot be fundamental. For basic reasons, it cannot be fundamental. It's only an approximate notion. It has to emerge from something deeper. And I'll just give you a feel for it. It has to do with the interaction of quantum theory and gravity. Quantum theory says that to make finer and finer measurements, you need to make what you use, for example, to see things at finer and finer resolution, you need to use light with finer and finer wavelength, higher and higher frequency. Well, we find out from quantum theory that the higher frequency is associated with greater energy. So as you probe smaller and smaller distances, you need higher and higher energies. No problem. If you just have quantum theory, no problem. That's perfectly fine. But when you get gravity involved, those energies turn into, are equated to mass. And so you're putting more and more mass into a smaller region of space. And at some point, you literally destroy space-time. You create a black hole. So at 10 to the minus 33 centimeters, the very notion of space ceases to exist. It has no operational meaning. And if you get frustrated and say, well, let me put more energy into it, let me try harder, what happens is the black hole just gets bigger and bigger and bigger. Another problem from quantum theory is that there are no local observables in space-time. If you give me a fixed size room, and I want to measure, say, the coupling of the electron to high precision in a room, it turns out that you can't do it because the measuring apparatus itself is a quantum system. It needs to get more and more precision. You need more and more degrees of freedom in the measuring apparatus. By the time you get enough degrees of freedom to get the precision you want, you've collapsed the room into a black hole. So what quantum mechanics entails is, again, with gravity, and this is not now a thing of the small, this is not at the Planck scale, this is at the scale of the room. So this is not just a problem that we can sort of throw away because it's just tiny stuff. This is any fixed size room, there are no observables, 0 observables available. So yeah, and the reason is you'll create a black hole. So that's a little bit from the physics side. What about from the evolutionary side? Now, evolution by natural selection is also one of the pillars of modern science. So I put general relativity, quantum field theory, and evolution by natural selection are sort of the 3 big pillars. Now, evolution by natural selection, most of us would think that we've evolved to see reality as it is. Not all of reality, but those aspects of reality that we need to survive. And one reason we believe in space and time and physical objects is because we see them, right? Why do I believe the moon exists when no one looks? It's because when I look up there, I do see the moon, and everybody else agrees that they see the moon. We trust our senses to tell us truths, not all the truths, but the truths that we need. And even someone like Einstein said, "How you really expect me to believe that the moon only exists when I look? Or do you think the moon ceases to exist when I don't look?" It seems inconceivable to us. So there's this question: does natural selection favor sensory systems that tell us truths about objective reality? Because that's sort of the reason why we intuitively believe in space-time and physical objects, because our sensory systems report space-time and physical objects. Well, it turns out that the answer is very, very clear, and the answer is no. The probability is precisely zero. This is a theorem. This is not a hand wave, this is the theorem. Evolution by natural selection predicts that the probability is precisely zero, that any sensory system of any organism will tell you any truths about objective reality. No structure of objective reality will be reported by the sensory systems. Instead, what natural selection does is it shapes our sensory systems to keep us alive. Full stop. Seeing the truth is not necessary to keep you alive. So in other words, what evolution has given us is more like a visualization tool, a virtual reality that guides adaptive behavior and hides the truth. It's like playing a video game, a virtual video game, where to play the game, the virtual reality is very, very adaptive. Someone could try to play the game by seeing the reality, which in this metaphor would be the diodes and resistors in the supercomputer that's running the game. But if you had to toggle voltages in the supercomputer to try to win the Grand Theft Auto race game, good luck. You would never win. You would lose against someone who saw none of reality and just had a very nice graphical interface. And that's what evolution gave us, is a graphical interface that hides the truth. So space-time is just our headset. It's not objective reality, it's just a headset. And physical objects are merely icons in that headset. And that includes brains and neurons. They exist like in virtual reality. When you turn your headset over here and I see in Grand Theft Auto, I see a red Camaro, then I turn over there and I see a green Mustang. I create the green Mustang when I look, and I delete it when I look away. Same thing with brains and neurons. We create them when we see them, and we destroy them, garbage collect them when we don't need them. Or you can think about evolution as giving us a user interface. If you had to toggle voltages in your computer to write an email, your friends would never hear from you. It'd be too hard. We have user interfaces that hide the truth. You don't even need to know about circuits and software. You don't even have to believe in them. You can just control them without even knowing what they are. And that's what evolution gave us. So it gave us space and time and physical objects as a user interface that just simply guides adaptive behavior. And so physicalism is simply the rookie mistake of taking our headset for the truth. It's like someone who thinks that the Grand Theft Auto game is the final reality. There's no supercomputer behind it. There is a supercomputer behind it. Obvious objection, I'll just throw it out. You know, Hoffmann, if you think that train coming down the tracks at 200 miles an hour is just an icon in your user interface, why don't you step in front of it? And when you're dead, and your silly theory with you will know that the train was real and it really can kill. And I wouldn't step in front of the train for the same reason I wouldn't take my little icon, a blue icon for some file I've written, and carelessly drag it to the trash can. Not because I take the icon literally, the file is not literally blue and rectangular, but I do take it seriously. If I drag that icon to the trash, I could lose my work. And that's the point. Evolution gave us space-time headset and physical objects to keep us alive. So yes, we have to take it very, very seriously. But it's a logical error to say that therefore we're entitled to take it literally. We're not entitled to take it literally. So that means that the physicalist approach is fundamentally flawed. Space-time is doomed, it's not fundamental. Physical objects exist when we perceive them and not otherwise. So there's no causal arrow from space-time and physical objects to consciousness. There just can't be. Now, I don't know what the true answer to the mind-body problem is. I just don't know. But I know that our best scientific theories are telling us that it's not something inside space-time. Space-time itself is just an approximate concept. There's something deeper. Physicists are now trying to figure it out. Nima Arkani Hamed and others that, for example, are coming up with things like the amplitude hedron, the sociohedron, and cosmological polytopes. These are structures in which space-time does not play a role. There is no quantum theory, there is no special relativity. These are structures beyond space-time, and yet they show how space-time can emerge as an approximate concept from something deeper. So it's in that spirit that I'm also looking for something deeper, beyond space-time, that can actually give me the structures that the physicists are finding. So they found these amplituhedra, cosmological polytopes. Maybe we can find a deeper structure that shows where these things come from. So this is where, again, I'm probably wrong, and the whole point is to be precise so we can figure out as quickly as we can where we're wrong. The idea is that somehow consciousness, what I'll call conscious agents, are fundamental, and somehow they give rise to what we call the physical world and physical objects. So the idea is this, that there's a vast social network of interacting conscious agents. This is the proposal. So reality is not space-time. Reality is consciousness, but a society of conscious agents. Think of like the Twitterverse. So there are a bunch of agents tweeting, some are following, others are being followed, and so forth. So this vast Twitterverse of interacting conscious agents. Now, in the case of the Twitterverse, there are tens of millions of users, billions of tweets. It's just too complicated for anybody to completely grasp. So what do we do if we have a vast social network that's just too complicated to understand? Well, we use visualization tools. I'll get a nice virtual reality headset, a VR tool that lets me see what's trending in New York, what's happening, zoom back, maybe what's happening in all of the United States, go over what's happening in China, zoom into what's happening in a particular little street, and this little, what's really being tweeted right by this person at New York City on Fifth Avenue. So a good tool will let me zoom in and zoom out, because otherwise we would be overwhelmed by the social data. That's what space-time and physical objects are. They're merely a headset. They allow us to have interaction with other conscious agents. When I interact with other people, my headset is giving me the best connection with agents that I possibly can have. But so here's the idea. So on the left is this vast network. It's too complicated. So on the right, I have a headset that allows me to have a visualization tool by which I interact with that network of conscious agents. So the mathematics then is dynamics on graphs. So this can be completely rigorous, it can be completely mathematical. We can look at the long-term behavior of dynamics of social networks on graphs. This is a new mathematical field, but it is a potentially very, very precise field. So you sort of see this firsthand when you look at your own face in the mirror. You know that what you see immediately in the mirror, your skin, hair, and eyes, is just skin deep. It's very superficial. What you don't see directly in the mirror, your hopes, your dreams, your aspirations, your love of music, the whole rich world of your conscious experiences, it's hidden behind a very, very trivial symbol. Your face is trivial compared to the rich world of conscious experiences behind it, and it in no way resembles that world. A smile does not resemble happiness. A smile is a signal into our user interface that tells us reliably that someone might be having a conscious experience of happiness, but it's not the same thing. So with humans, this visualization tool of space and time gives us some insight, but poor insight into the consciousness behind the face icon. So I'm not saying that the face is conscious. Your face and your body are not conscious. Your face and your body that I see are just my icon that I create, but it's a portal. In some sense, that icon is a portal into your consciousness. If I see your face icon smile, I have a portal into your consciousness, and I can believe that you're probably happy. If I see you crying, I can believe that you're probably feeling sad. In the case of the cat, my portal is dimmer. I have much less insight into the consciousness that I'm interacting with when I have a cat icon. With a mouse icon, even less. With an ant icon, even less. When I get down to microbes, my interface is giving up. But interfaces have to give up. That's the whole point. They're there to simplify. They're there to ignore most of reality and simplify what they don't ignore. So it's no surprise that at some point, things don't look conscious. So in other words, from this point of view, the distinction between living and non-living that we take as fundamental is a trivial artifact of the representation limitations of our user interface, of our visualization tool. It's a trivial, and it's a rookie mistake to think that there is a fundamental distinction between living and non-living. There's just a distinction between icons that give us more insight into consciousness and ones that give us less. When we get down to rocks and atoms and so forth, our interface has given up. But of course it had to. So, one last question. When it comes now to the possibility, is it possible for us to create artificial intelligences that are conscious? Well, the standard view would be to say, well, could we get unconscious silicon and software that's fundamental somehow to get complicated enough that somehow the magic of consciousness emerges? And I'm saying that that whole framework is wrong because space-time and matter themselves are merely visualization tools. So instead, the question is this, from this new framework: is it possible to rejig our interface? So space-time is just our interface. Physical objects are just our interface. Is it possible, once we understand how this network of conscious agents and have a mathematical model of how that projects, say, into Nima Arkani Hamed's cosmological polytope, then how that creates space-time? So if we can get that mathematically precise model that goes all the way from a mathematically precise dynamics of conscious agents through, say, a cosmological polytope into space-time, so we've really got the ability to reverse engineer our interface of space-time. Will we then have the ability to open new portals, to rejig our interface, to open new portals into this pre-existing realm of conscious agents? So this is not creating new consciousness, it's opening new portals into conscious agents that already exist. And for what it's worth, I think the answer is yes, that when we get this mathematically precise, we will be able to open new portals. We'll also be able to play with space-time itself, because space-time is not fundamental reality, it's just an interface. Once we understand how to play with it, we will. So with thanks to my collaborators, many people who worked with me on this, but I don't blame them for any of my mistakes. I take full responsibility. Thank you very much.